Hello everybody and welcome to the homework helper for stats number 1. So this is it says 9.1 because it's from the secondary 3 module 9, but we'll just consider this statistics number 1 as far as we're concerned. All right, let's go ahead and dive into this. So the very first section is we're talking about standard deviations and percentiles. And so the very first one says Jordan scored a 53 on his math test. The class average was 57 with a standard deviation of 2. So we know the class average. Okay, this is since our average is our mu, and we know the standard deviation, we know that's our sigma, we can now rebuild what this would look like. If this were to be set up as a bell curve, so to speak, we know that our average is going to be 57 here, and then our standard deviation is going to be 2. So that means if we go up 2 points, that's going to be the first standard deviation, so that'll be a 59. Second standard deviation would be a 61. Third would be 63. And then after 3 standard deviations, we tend not to pay attention to that. But likewise, it also goes backwards. So this would be a 55. I can subtract 53, 51, and we'll call it good. All right. So now here's the tricky part. So our boy Jordan scored 53. So he scored 53 right here. How many standard deviations below is that? Well, 1 standard deviation would be 55, so 2 standard deviations would be 53. So we would say that 2 standard deviations below. Okay. I'll skip number 2 because it's a very similar question, but let's look at number 3. Number 3 asks us to rank the data sets in order of the greatest standard deviation to the smallest. So we have to actually figure out what the standard deviations are in these data sets. In data set A, we see that we go 1, 2, 3, 4. So they're evenly divided, and so we're going to say the standard deviation is a 1, 2, 2, 2, 2. There's no standard deviation there, so we'd say it's a 0, 2, 4, 6, 8. That appears to be a higher standard deviation of 2, etc. And then we would rank them accordingly. All right. Robin made it to the swimming finals for her state championship meet. The times in the finals are below, 2 minutes and 10 seconds, 0.3, etc., etc. If her time was 2:12.7, what percentage of her competitors did she beat? Okay, so 2:12.7. So where would that be? 2:12.7. That would be right here, right here. So how many of her competitors did she beat? So this was Robin. So how many competitors did she have? 1, 2, 3, 4, 5 competitors. How many of them did she defeat? 2. So it would be 2/5, which is 40%. Boom, easy enough. For this one, it says using technology, identify the mean and the standard deviation. So using technology, there is posted on the blog a standard deviation calculator. You can also just Google search standard deviation calculator. That's how I found it. You can Google search standard deviation calculator and you'll be able to find one. You plug it in, it'll do it all for you. It's pretty sweet. Okay, let's go on to the next section, the set. This asks us to identify the properties of a normal curve. So essentially what we're looking at is we're trying to make sure we know what normal properties we know. So what are the normal properties that we found? Well, we know that the mean, median, and mode are the same. That's one of the properties. There should be a bell curve. That's one of the properties. There should be some sort of sigma or standard deviation. Okay. There should be the bell curve also speaks to the symmetry. Symmetry, we kind of talked about the symmetry that we're expecting. It looks the same on the left and the right. So essentially for this one, look back at our opening work, but specifically number 7. Specifically problem number 7 should give us a lot of the information of what it should look like. So when we look at something like number 7, it's this beautiful curve. There's these lines with the standard deviations and the percentages and all that sort of stuff. When I look at something like that and I compare it to number 7 here, not this number 7 in our classwork, but when I look at this problem, this has nothing. There's no spread of information. There's nothing. What do I have? Well, it appears that my mean, median, and mode are the same, right? That's all the same. but there's no spread. So would I say, could I model this with a normal curve? No, right? What would the spread be? There's one standard deviation away is still 0. Like, it doesn't make any sense. So this does not work. And you'll kind of play this game for all of them. Like when we look at number 8 here, we see that it actually valleys in the middle, right? You know, we have a mode. This is the mode. It's the most common occurring. We've got a median here thanks to the box and whisker plot. They're not the same. You know, when I look at this, I don't really see any normal properties at all. I would say that there's none. There's none properties that resemble the normal graph. So no way can I do this. And so that's essentially what you're going to do is you're going to take all that work we did in the pre-section, you know, when we're talking about these parts and, you know, this stuff here. When we were talking about all of this, here's that number 7 I was talking about. This graph here is money. But when we identified all the things that led to normalcy, apply those things from the pre-work to these problems. Like, let's look at number 10. Number 10, yeah, mean, median, mode are all the same. Those look the same. We've got a nice curve. We've got a nice curve here, right? It appears to follow something like a standard deviation, right? So yeah, I would say this one we could model. But it's applying those things to each of them. Okay. And then finally, here we go. Recalling inverses. So this is a bit of a review from the algebra stuff. Don't stress out too much about it. Like, this won't be test material, but it's still useful to think about the algebra levels or the algebra stuff that we do. So when I'm looking at number 16 here, it wants me to find the inverse. Now, what is the inverse? The inverse is literally just taking your x and your y and swapping them. So if I have f of x equals 3x squared plus 2. Well, f of x is kind of my y, so I'm just going to rewrite this as y equals 3x squared plus 2. And to invert it, all I do is I switch my x and y. So I have x equals 3y squared plus 2. But now I want to get y by itself, so I just do all the things to get y by itself. I'm going to subtract 2, x minus 2 equals 3y squared. I'm going to divide by 3. So x minus 2 over 3 equals y squared. I'm going to square root both sides. I'm going to carry this over here. So y would equal plus or minus the square root of x minus 2 over 3. And then I would just rewrite this in function notation, the inverse of f of x. So I'm going to do that that negative 1 means the inverse equals plus or minus x minus 2 over 3. And I've done it. And all I did was swap my x's and my y's and then solve for my new y, where my new y is. And that's all that this is asking us to do. For this one, for number 20 here, it wants us to plug one function into the other. It says determine if the following functions are inverses by plugging f of g of x and g of x of x. So we can figure out if they're inverses by plugging them into each other. So what I'm going to do is I'm going to do f of g of x here. So instead of x, I'm going to write what g of x is here. So this is going to be 2 instead of x, 1/2 x minus 3/2 plus 3. Distribute. That's going to be x minus 3 plus 3. That's going to equal x. Done. Okay. So if f of g of x equals x, let's try it the other way. What is g of f of x? So g of x is 1/2, but instead of x, it's 2x plus 3 minus 3/2. So that's going to equal, if I distribute, that's going to be x plus 3/2 minus 3/2. This will simplify, so it's just x. So you see when I do both, when I plug f into g and when I plug g into f, I get x as my output. This means that they are inverses of each other. They do invert because when we plug them into each other, we just get our variable. So I would say, yeah, dog, this is an inverse. Woohoo! And that's it. That's your homework. All right, best of luck, everybody.